active contours, scissors and level sets. Hello friends, welcome in this session of level sets. We are going to discuss today the scissors and the level sets, which are the part of active contours. The role of active contour is to segment the image for various shapes and sizes. The snakes are the first part of active contour, but it has a limitation that segmentation resulted may not be accurate. For that purpose, the level sets and the scissors are the effective tools which can be used for segmentation of the image for various sizes and shapes. Scissor is a technique which allow user to intervene in between, give some external controls, and based on those inputs, a perfect segmentation can be achieved. So user basically provides some markers and the algorithm will follow those markers in order to detect the boundary of a shape. So scissors are better than the snakes. On the other hand, if there is a change in the topology of the object, then scissors may underperform, and in that condition we have a good option of level sets. So while segmentation, if the topology of the shape or of the object changes, then with the help of level set we can perform the segmentation very effectively. So snakes, level sets and the scissors are very effective mechanisms which are the part of active control which are used for segmentation. So let's discuss today the scissors and level sets. Active contours, they allow user to roughly specify a boundary of interest. So for that purpose, generally we use snakes. So probably if the object of interest is to detect this particular object, then while segmenting, the lines may follow the outer boundary of the object, but the results may not be perfect. There may be some error during segmentation. The results may be unpredictable and it may require additional user-based hints to achieve the desired result. An alternative approach, therefore, is to have the system optimize the contour in real time as the user is drawing. Therefore, during that particular object tracking, whenever the boundary starts and whenever it starts deviating, the user has to provide some input so that it can follow the exact boundary of a given object. As you can see in this image, the current free point is this, and whenever the algorithm tries to track the object, then it does not follow the exact boundary of a object and the results may not be accurate. It has to follow the boundary which is the actual boundary of the shape as drawing right now. As the user draws a rough outline, the system computes and draws a better curve that clings to high contrast edges. So this ensures that while drawing, the boundary is accurately tracking the actual outer line of a given object. To compute the optimal path curve, we can perform the imagery processing, like we can perform various operations that will enhance or uplift the edges, or the contrast of a given image would be enhanced. So for that, histogram equalization can be used, or point processing algorithms can be used, which can uplift the changes or high frequency components in a given image, and by uplifting the high frequency components or edges, then segmentation would be very optimal. For example, let us consider the application of lane processing. The lane is an image where the road surface which is more inclined towards darker part and the lane markings which are typically white and yellow. So these are the 2 or 3 combinations of intensities can be seen. If one tries to detect the lane markings which are typically white in color by assuming all lanes are of white marking, then we can uplift the white intensities in the resultant gray image and we can have a perfect detection of the lanes. So for that, a point processing algorithm can be used which can convert all range of white pixels into a binary 1 and all road pixels into binary 0. So by doing this, in the resultant binary image we have only lane markings as the outcome, and by improving the contrast level in this manner of a given image, we can get the segmentation result in more appropriate manner. We can also associate the low cost with edges for the boundary. So by doing this, the edge detection is feasible and that will help in turn to segment the object. All outer boundaries or silhouette of the objects can be visible.